So your word processor file is doing what? Your MS Word. In the MS Word, if you see, if you're writing something, immediately it's the spelling and grammar gets corrected, right? That one thing happens. Another thing, it always show what is the correct syntax of the words, what are the synonyms are there that can be done. So these are there in the advanced versions of MS Word, correct? So basically, you can say that MS Word is one single process, right? It is a one single process running in the memory. But actually, what are the things that are happening together? You are writing that same. It is checking the correct, checking the word that is also happening. It is checking all the words. It is checking all the corrections. That is also happening. But again, why are these processes so? Is the MS Word a single process or multiple process which are running concurrently? The answer to this question is that MS Word is a single process. But these are different, what you can call different threads of control, which are running concurrently with your editing. That means when you are typing, it is the error checking, the grammar checking, the spelling checking, all are going concurrently with your MS typing. Okay. So basically, the thing is that process is a unit of control, that is fine. But it is the thread is also can be called as a unit of execution within a basically within the operating system. You understood this one? One concept?
Yes, sir.
Yes, sir.
So the concept again takes a multiple important things, right? Now let us think about the Google server, right? Now you know about the fork system command. The fork system command creates the child process, right? Now in the cases, what is happening if the Google, let us think that the Google is working on a Linux server, right? Which it is actually, I think so. So basically, it can be multiple operating systems also. So, but let us think it is running on a unique Unix kernel, and it has to create a separate process for each service request. So around the world, around there are 3 billion people who are typing something on the Google search box, right? What would happen if the Google creates a separate process for each of those 6 billion users? Right. So for each service request, the Google creates a process. That means it is creating a separate memory. It is creating a separate code section. It is creating a separate data section. It is creating a separate stack section. It is creating a separate heap section for each of the separate requests. So let us think that if it takes around 1 megabyte also of memory for each process, then how much will take for 6 billion? It's an easy calculation, right? 6 billion megabytes means how much? Or 3 billion megabytes means how much? It's huge, right? How much? Around 3 penta of 10 penta of data. So no RAM is built for that purpose, right? Even if you're building parallel RAMs, it cannot accommodate so many processes into together. This you understood? So what is the way out? What is the way out? Right? What is the way out? So for each service request, what we can do? We can create a separate thread for each service request. And what does the thread share? The thread shares the code section, the data section, and the what you can say the file that is request opening section. Those things that is open. And what does the thread that has separate which identifies itself from other threads? It should have an ID, it should have a stack, and it should have a separate register stack. In that way, it can serve billions of users across the whole world without creating so much overhead. This you understood what I said?
Yes, sir.
তাই তোমরা সবাই বুঝতে পারলে কি বললাম? ত্রিপুরারি সমঝ
Sir,
में आया? প্রীতম তোমরা
over.
প্রীতম
Yes,
বুঝেছো? সৌম্যজিৎ বুঝতে পেরেছো? দীপ্তিমান বুঝতে পেরেছো? ঋতুজা বুঝতে পেরেছো? বিদিশা বুঝতে পেরেছো?
Yes,
হ্যাঁ
sir.
কি নাতে বলো?
Yes, sir.
Any confusion
yes,
regarding
yes,
this?
sir.
Okay, fine. So now the thing is that what is a thread? Now let us define into a more formal definition of a thread. So a thread is a basic unit of CPU utilization. What is the process? A process is a unit of, what is that? CPU, that is CPU working, right? That is we learned in our previous class. Now, basic unit of work in a computer is the process. But what is the basic unit of CPU utilization? It is the thread. So what it contains different from other threads? A thread comprises a thread ID. It should have an ID. Okay. Now it should have a program counter. It should have its own program counter where the next instruction should be read. It should have a register stack attached with it. That means a process may be allocated multiple register stacks. Some of the registers may be allocated to a separate thread. And lastly, it should have a program stack. So where it can call different functions and global variables. Now, process creation is time consuming and resource intensive, right? So we learned from the Google example. That process creation is time consuming and resource intensive. Means you have to create separate code, data, heap, and stack section for each and every process. Why not we create a separate thread which shares the basically code, data, and the file open sections, files that are open sections, and the rest of the sections it can have separate register, stack, and a program counter. It is generally more efficient to use one process that contain multiple threads. So there is only one single Google server. They might be for country wise or district wise, which is basically creating a thread per user for every user. Okay, so that is how this thread operation is working. One second, recording is working. So we have already said about the MS Word. So MS Word is a single process, but there are different threads which do the different tasks. One does the editing tasks, right? One is doing the spell checking tasks. One is doing the grammar checking task. One is doing the synonyms check. One is doing the formatting task. So these are different threads of control within the same MS Word application, right? Which are doing all those things parallel. So when you are learning, you have learned Java, right? Do you know Java?
No, sir, we didn't learn Java.
Okay, it will be there in your next semester. So in Java, there is a separate chapter called multi-threading. You will learn there in the how many threads you can open. So there are two ways to open a thread. One is through the interface. One is through using the thread class. So that you will do in your next class. And that time this concept, if you remember it, it will be much more clearer to you in the next semester. So we can do some coding. Let us see if we have time in the next few classes. We will do something about it. Okay. So let us see what is the difference between a thread and a process. So the thread shares with other threads belonging to the same process its code section, data section, and other operating system resources such as open files and signals. So these are the things which are shared. Let us see: code section, data section, and other operating system signals such as open sources, open files, and signals. Okay. So let us color it actually. These are the things which are shared, right? And which are the things which are different from other threads? Thread ID, program counter, register set, and stack, which are different from other threads. So let us look. So a traditional heavyweight process has a single thread control. So whatever program codes you have written now, they have only one single thread of control, right? And if a process has multiple threads of control, it can perform more than one task at a time. So let us say if a process has multiple threads of control, right, it can perform more than one task at a time. So basically, the MS Word example, so we see it has multiple threads of control: editing, spell checking, grammar checking, synonyms checking, formatting. So these are multiple threads. One thread is doing the editing part where you are writing. One thread is doing the spell checking part where it is checking the spelling of yours, whatever you are writing. One part is doing the grammar checking, which is basically checking if the sentence is in the correct structure or not. And another thing is doing the synonyms checking. If the basically if any other words can be put into it, another part is doing formatting. So you see, this is a single threaded process. Single threaded process is what? One basically single thread of control. Okay, this is a single thread, and it has all the things allocated to it, that is code, data, files, registers, and stack that are allocated to one single thread, which are general simple programs that you write. Now, in this case, what you see that in this case, we are talking about multiple threads of control where there are multiple threads of control, right? Multi-threaded processes. And the code, data, and file sections are separate. These sections are basically shared. And this section, which is different from other threads of control, is the register, is the stack, is the registers, is the stack, and register ID, register stack, and whatever you can call the program counter. So these are the parts which are separate from each other and which identifies a thread from each other, right? So let us understand from the again this concept about a web server application using threads. So in the class when I was trying to explain you about the Google server, what we are doing, we are trying to explain how the Google server manages the whole thing. So even if you are writing a web server application, so your server must be very powerful. Server is a single computer, right? Your server is a very powerful server, right? Or it might be distributed system, whatever. So your server might be very powerful. But the thing is, the memory is limited. So to serve multiple requests, so you need what you can say optimize the use of your memory. So in this case, when the client can be thousands, millions, 1 billion, anything. So if they are requesting something, so what the server does, it creates a new thread of service to the request. So it created a service thread for serving this request, right? And then it starts again listening for client request. So it is the Google server is receiving multiple requests at a time. So it is creating a thread to service each request, right? So whenever you are typing something on Google server, what it is doing, a thread has been allocated to you, which is serving the things. That is how the web server works, right? Understood this one?
Yes, sir.
Hello, every one of you understood?
Yes,
Yes,
sir.
sir. Yes, sir.
And
Yes,
practicalটা
sir.
তোমরা জমা করেছো? প্র্যাকটিক্যালটা জমা করেছো তোমরা সবাই?
Yes, sir.
Yes, sir.
Okay, I'll check it that in the last of the class. Okay, fine. So threads, there can be two levels of threads. One thread that you write in your code, right? That is the user level thread. And there can be threads which are in the kernel level. The operating system operates this kernel thread. Now, depending upon the make of the operating system, so there can be single or multiple level threads. So generally, single processor operating system has only one thread of control, and this thread of control is alternately used by all other user threads. So user level threads cannot work on the kernel level thread directly. Only the operating system allows the user level thread to work on the kernel level thread, right? So kernel level thread are not accessible to the users. It is only accessible to the operating system. Now, depending upon the operating system, our operating system can create single, multiple, different parallel threads it can work upon. So, what are the advantages of threads? So, the first and foremost advantage of thread is responsiveness. So basically, if you are so sometimes you see that when you are working, so it's a very old computer you have, and you are writing some MS Word document. So in that case, what is happening? In that case, you have opened this Word document, and sometimes you see you are writing something, but it is not showing. That means the thread that is allowing you to write something is not working. That the editing thread is not working. But all other threads are working. That is, the grammar check is working, the error thread is working, the synonyms check thread is working. So every thread is working. So you know that the system has not hanged. Okay. You say no, the system has hanged. But you see all other systems are working, only that part is not working. You think that only this part is not working, some problem is there. But in general, my system has not hanged or it has not stopped working. Right. So basically, it allows, so the responsiveness, so it allows responsiveness of a program, right, to the user. Is an interactive. So multi-threading is an interactive application which may allow a program to continue running even if a part of it is blocked or is performing a lengthy operation, thereby increasing responsiveness to the user. So anything, any system, if it is responsive to you, you know it is a better system, right? So, but that is one of the advantages of threads. Another importance of the threads is resource sharing. So threads share what? So basically, that is code, data, and whatever operating system resources are there, they are shared by all the threads. So if threads are shared the resources, there is an optimization point reached where all the resources are used in an optimized fashion. So the threads share the memory and the resources of the process to which they belong by default, allowing an application to have several different threads of activity within the same address space. So which they belong by default, allowing an application to have several different threads of activity within. So basically, within the same address space, you can have multiple threads of activity which share your resources. Another important objective of the usage of threads is economy. So what is the very important objective it is? It is more time consuming to create and manage processes than threads. So basically, when you are creating a new processes, much more time is allocated to it, much more resources are allocated to a process. But if you create a thread within the same address space of the process, then it is much more economic, means it is much more scalable, right? The economic is much more, so basically you are using the same resource space. So basically you are the utilization, optimized utilization happens more. The last thing is scalability. So that the benefits of multi-threading can be greatly increased in a multiprocessor architecture where threads be running on parallel on different processors. So there are multiple processors are there, and when the threads are running on multiple processors, so a degree of concurrency is used. One second, just one second.
Sir, can you repeat those advantages again?
হ্যাঁ বলো।
স্যার আপনি অ্যাডভান্টেজেস গুলো রিপিট করতে পারবেন? একটু
Okay,
কিছু এক্সাম্পল বা এরকম কিছু।
one second. So responsiveness you have understood.
Yes.
Okay, so one of the parties, one of the processes might be blocked, but other threads are working. Resource sharing is basically you are using the same memory. A process is allocated a memory. Let us say 10 megabytes of memory is allocated to the process. Understood?
Yes, sir.
Now, when 10 megabytes of process is allocated, let us create 5 threads. So, and the 5 threads are using 1 megabyte of space. So, one thread for 1 megabyte. So, the same memory is used for the process, and there are multiple, what you can say, multiple work is going on, different works, right? Each thread is allocated different works, but they're using the same memory. But if you are using the different processes, so you have to create 10 processes different, right? So 10 into 5 is around, sorry, if there are 5 different processes are there, or then we have to create 5 different processes. So if there is no thread, so it will, the memory required will be how much? 5 into 10, 50 bytes or 50 megabytes, right? But if you are creating threads within the same process, all are working on a different objective. So in this case, you are sharing the same memory, that is 1 megabyte. So within the same process space, you are doing all the job. Understood this one?
Yes, sir.
না ডাউট থাকলে বলো। See, this is a, let us say, computer memory, right? And this is process, let us say this is process P1, this is let us say process, this is P2, and all those things are going on, right? So let us say P1. This is process P2. And let us say this is process P3. Okay, now the thing is that let us say they are allocated some memory. Okay. Let us say this is 150 bytes. Okay, so process P1 is allocated 50 megabytes, process P2 is allocated and 50 megabytes, process P3 is allocated 50 megabytes. Right. Let us think of an the objective is working on a warp file. Let us say any system program. Let us say a compiler which requires three codes. That is one for the linking. The second is for the loading, and let us say think of the and this is converting into assembly language code. Right. Now let us think linking is allocated to a separate process, loading is allocated to a separate process, and converting is allocated to a separate process, that is P3. All are working doing the same compiler job. Now in this case what happens? In this case, what happens? There are three processes. 150 megabytes are fully allocated. But why we require three other processes which are required concurrently? We can do we can do all these processes together within the single P1 process, that is the 50 megabyte process. And in here, all we need to create is all we need to create is three threads. Let's understand. So let us say this is thread 1. This is thread 2. And this is from thread 3. Right. And only one process P1, that is a simple compiler, it creates three separate threads within the same 50 megabyte space. It doesn't need to create a separate process for all these purposes. So each thread will work basically simultaneously or concurrently to do all the jobs within the same address space of 50 megabytes. So thread 1 is allocated some 20 megabytes, loading is converted some 20 megabytes, and thread 3 is converting is something loaded of 10 megabytes. So within this space only, within this memory address space only, they can do all this. Right? Understood?
Yes.
बुझले?
नहीं सर, समझ में नहीं आया, एक बार और समझा देते ना सर।
अच्छा देखो, समझ में अभी नहीं आएगा। तुम लोग जब जावा में कोडिंग का क्लास करोगे ना, थ्रेड्स का, तो तुम्हें समझ में आएगा। देखो, जब भी हमें कोई प्रोसेस बनाते हैं तो उसमें कुछ मेमोरी एलोकेट हमें करना पड़ता है, ठीक है ना। तो सोच लो, इसका है मेमोरी एड्रेस स्पेस 50, P2 का है कुछ लेट अस से इसका 100 है, मतलब इसका भी मेमोरी स्पेस है हमारा लेट अस से 50 मेगाबाइट का इसका भी साइज है, और इसका भी साइज है, P3 का भी साइज है 50 मेगाबाइट। सो ईच एंड एवरी वन हैज सम 50 मेगाबाइट स्पेस। नाउ a compiler is a very heavy duty program, so it does three things together, that is linking, loading, and converting. So these are all heavy tasks, and if this heavy task, if you use a single heavyweight process that uses a single thread of control, then let us think that P1 is a separate process which does the linking only. P2 is the separate process which does the loading only. And P3 is the separate process which does the converting only. That is from a high level language to a low level language. Now, why do we require these three separate processes? So each will require, one process will require 50 megabytes, but actually it requires how much? Some 10 megabytes. P2 is P2 requires how much? It is 10 megabyte, but how much it is using? 50 megabytes. Converting requires 5 megabyte, but how much space it is using? 50 megabytes. So it is better that you create a single P1 process and you create three separate what you can call separate threads of control within the same address space of P1. मतलब वो जो एड्रेस स्पेस यूज करेगा वो 0 से 50 मेगाबाइट्स के अंदर ही रहेगा, लेकिन जो थ्रेड्स ऑफ कंट्रोल रहेगा वो 3 रहेंगे, जो कि अगर एक ही प्रोसेसर होगा तो वो मतलब एक टाइम में एक थ्रेड काम करेगा, दूसरे टाइम में दूसरा थ्रेड करेगा, and in the third basically they will interchange the process concurrently so that they all are working together within the same address space of the process P1. Okay, so I am creating three separate threads within the same address space of P1, right? In that way I can what you can say we can so what we are discussing about, so I have created resource sharing, so the memory is shared between these three threads in implementing the compilation task. Understood?
Yes, sir.
ठीक है, थ्रेड बनाना कोई बहुत मुश्किल काम नहीं है. जावा में तुम लोग जैसे ही से मल्टी थ्रेडिंग ये थ्रेडिंग आर्किटेक्चर पढ़ोगे, that time only you will understand that threading is basically nothing actually. So there is a class called thread or there is an interface called thread. You can implement any number of threads within the same address space. What is the difference? You may think that is thread may be different from a process. No, threads works within the same address space of the process. Memory वही है, memory is the same. They are sharing the resource, right? They are sharing the code, they are sharing the memory, everything they are sharing, but they are working different purposes. One is doing the linking, one is doing the loading, one is doing the converting, but they are अगर एक ही प्रोसेस रहेगा, एक ही अगर प्रोसेसर सिस्टम रहेगा, तो दे आर यूजिंग इट बाय इंटरचेंजिंग. एक थ्रेड कभी काम कर रहा है, दूसरा थ्रेड कभी स्लिप करके दूसरे को काम करने दे रहा है. दिस वे दिस होल प्रोसेस इज वर्किंग. अंडरस्टूड?
यस सर.
नहीं ये क्लियर कर लो बाबा, ठीक है? मैं दूसरी बार नहीं पढ़ाऊंगा.
हाँ सर समझ गया.
एनी मोर? Any one of you understood? So let us see how does it work. So let us open the Java thread tutorial, right? So let us take any Java from W3 schools. Let us take it. See, there is a thread class. So whenever we want to implement a thread, we have to extend from the thread. And there are two ways. One is the runnable interface. One is the thread class, right? There are two ways to implement the thread, right? So let us see. There are how to start a thread. Thread.start, and it will run this one. Whenever you are starting thread.start, it will execute public void run. So this code is running in the thread, right? So this code has only one single thread, that is this one, main thread. Okay, and whenever it will do this run this function, it will basically implement this one, right? This code will implement this one. See, if you want to try it yourself, so let us see. Let us run this code. See, so this code is outside the thread. System.out.println, this code is outside the thread, and this is the thing, that is this code is running in a thread, right? So whenever we do thread.start, it will start this one. This code is running in a thread, and and when it completes the task, then it will print this system. This code is outside the thread. Okay, that is how the things work. Let us work another example. Okay, let us do two threads actually. See, this is one code, right? Class test multitasking extends thread example. So the what is your task one, right? And there are three codes, three threads we have opened: T1, T2, and T3. Although they are doing only one single task, that is task.1, means it will print task 1, right? And whenever we are testing it, see, first T1 will start, so it will print task.1. T2 will start, it will print task 1, it will print third task. So T1 is running first one, T2 is running this one, T3 is running this one. So all are running within the same address space of the same process. Understood?
Yes, sir.
Yes, sir.
Everyone understood? So you see, within the same code only, I have implemented three threads, but they are doing a common task. Right? Understood? এই বুঝে থাকলে বলো, নইলে আরেকবার বোঝাতে হবে।
हाँ सर, समझ गए सर।
এই সোনিয়া, প্রীতম, সৌম্যজিৎ,
Yes,
দীপ্তিমান,
sir.
পূজা, রাহুল,
Yes, sir.
মনীষা, সবাই বুঝেছিস তো? So that is about the Java
Yes,
threads,
sir.
how the Java threads work. So Java threads are user level threads. So internally, again, there are operating system threads which implement the user level threads. Okay, understood?
Yes, sir.
Okay, fine. So economy is, so it is more time consuming to create and manage processes, right? So if you are creating multiple process, it is much more time consuming, right? And it is much more overhead. So benefits of multi-threading can be getting a multi-processor architecture. So if there are multiple processors, if nowadays you are using 2-core or 3-core systems, in those cases, you can allocate one thread to run on each processor. That is, the kernel level thread will run on each processor. So if you're writing a single program which are implementing, let us say, 4 threads, so the operating system will manipulate the code to implement each thread on a single processor. Understood? Hello?
Sir,
Yes,
can
sir.
you repeat that another time?
No. Let us say. So let us see how does this work. So we'll understand in this example. So let us say there are many to one model. So there is only one single thread of control is there, right? In the kernel level, there are two types of threads. One is the user thread, what you just seen, and then there is the operating system thread, which operates only one kernel level thread. So the many to one model maps many user level threads to one kernel thread. So how does it accomplish the task? So the kernel level thread is basically simultaneously used by doing some time multiplexing among the user threads. So one at a time. So sometimes this thread is working, sometimes this thread is working, sometimes this thread is working, sometimes this thread is working. So in this many to one model, this kernel level thread is implemented, right? In the one-to-one model, what happens? The operating system can create within itself multiple threads, and it can allocate one thread to one user thread, right? In that way, the one-to-one model works. Now, one of the disadvantage of this kernel, that is many-to-one model, when there is only one operating system kernel thread and there are multiple user threads. So what is the disadvantage is this, that if there is a blocking system call is applied on this operating system thread, so nothing will work. So everything will stop. In this case, there is one disadvantage of this one-to-one model where the operating system can create single thread for a single kernel level thread for an user thread, is that there is an overhead of creating so many threads. But these are all basically these disadvantages are solved by many to many threads. So there are multiple kernel level threads, and some of the user level threads are allocated to each kernel level thread at a time. So in that case, the system works nicely, right? So what was the question again? Okay. So let us say in the kernel level thread, the operating system works on the kernel level threads, right? So for each kernel, there let us say one kernel thread is allocated to one processor. So what happens in this case? If you're writing a simple program, right, in a simple program of 3 threads, so they are working parallelly among the 3 processors. So that is one of the advantages about parallel processing. So the in the many to many model threads, if there are multiple processors, it allows multi-processing. Parallel programming. So it is running. So one job is basically divided among multiple jobs, and the job can be done in a much lesser time. That is how this system works. You understood?
Yes, sir.
Yes, sir.
Hi, Sonia.
Yes, sir.
Yes, sir, I
দীপ্তিমান
understood.
দীপ্তিমান বুঝতে পেরেছিস? দীপ্তিমান দীপ্তিমান বুঝতে পেরেছো?
Yes, sir.
Okay, fine. So there are three thread libraries are there: POSIX, and there's Win32, and there's the Java threads which you just seen, just from the example. Okay, so in a later few classes, we'll let us say if there is some time left, we'll work on this one, thread libraries. Okay. তো এটা তোমাদের এবার এই ক্লাসে অ্যাটেন্ডেন্সটা তোমরা এটা চ্যাট বক্সে দিয়ে দাও। এই ক্লাসে অ্যাটেন্ডেন্সটা তোমরা চ্যাট বক্সে দিয়ে দাও। আমরা নেক্সট ক্লাসটা अराउंड 11:05 স্টার্ট করব। তোমাদের আমি এটা পাঠিয়ে দিচ্ছি, তোমরা এটা পড়াশোনা করো। Okay, so around 11:05 we'll start our next class.
Okay, sir.
Okay, fine. So I'm sending you this one. So I'll send you all the PPT slides in one single bunch. That would be a better idea, and you can study them together. I'll send you right today only.
Okay, sir.
Okay, fine. Thank you.
Okay.
Thank you, sir.
ठीक है सर,
Okay.
धन्यवाद
सर।
सर।